Good morning everyone. I trust you had a good half-term break and that you are ready and raring to go for another half-term of work. It's clear, isn't it, from the government advice that we're not going to see Year 9 back in schools this half-term. So we've got to make the most of this time, and particularly given the topic we're about to start, because we're about to get into the topic that covers Pythagoras and trigonometry. Two really key topics at higher GCSE, so understanding them is absolutely essential. Another thing that normally takes place in this half term is that we take the two top sets in Year 9 and change them into a set 1 and set 2 going into Year 10. Now we have plenty of data to support that decision from earlier in the year, but for those of you who have been engaged and working hard and submitting work when requested, you are doing yourself no harm whatsoever in terms of that decision, and Mr. Godber and I will be having to make those decisions towards the end of this term. So let's start today with a reminder about angles in parallel lines, and in particular the three rules that you need to remember. And the three rules are rules that you're expected to remember the names of, because you often get questions which ask you to explain why you get a particular answer. So here's the first rule. The first rule is that corresponding angles are equal. So I've got here a set of parallel lines. They're marked with little arrows to indicate they're parallel. And I've identified an angle here. I've called this angle, this isn't an L, this is just a little angle symbol, angle BEF. I hope you can see why, because to get it you go from B to E to F. I could have called it angle FEB, same thing. I know that angle BEF is the same as angle DEH. That's nothing to do with parallel lines. That's because I know that vertically opposite angles are equal. That's another angle rule. But I'm more interested in the angles up here that are the same. And the angle that corresponds to angle BEF is this angle here. This is angle GBC. And that's because this line here is straight and it is crossing two lines that are parallel, the four angles here, 1, 2, 3, 4, will be the same as the four angles here, 1, 2, 3, 4. And therefore, the corresponding angles, so I often refer to this as top right, the top right angle at this junction is the same as the top right angle at that junction. Similarly, this angle here. So this is angle DEB, that's the same as this angle here, angle ABG. They are corresponding angles, and I could have said the same about the angle down here and the angle down here and the corresponding angles up there. So corresponding angles are equal. The second rule is not a new rule at all, because if you understand the first rule, you'll be able to do the second rule. Alternate angles are equal. So here's an angle. This is angle BED. Now I know that angle BED will be the same as angle ABG, because they're corresponding, using the rule we've just had. But remember the vertically opposite rule that I said that those two are the same as? So that means that this angle here is also the same. So that's angle CBE, or I could have called it EBC, doesn't matter. Those two are the same. They're not corresponding, because this is top left and this is bottom right, but they're the same, and we call them alternate angles. I could have done the same with this angle here. So this angle here is the same as this angle here because it's corresponding, and because of vertically opposite angles, that's the same. Those two are the same, not because they're corresponding, we call them alternate angles. Now, the corresponding and the alternate angle rules aren't actually two rules at all. They're the same rule, but they're given two different names because Here we're saying, right, this angle is the same as the corresponding one at this junction. Here we're saying this angle here is the same as the corresponding one at this junction, but that means it's also the same as this one. So it's sort of two rules wrapped into one. And they're sometimes given nicknames. This angle here, this rule here, corresponding angles, is sometimes called F angles, because if you sort of lasso the angles, you get an F shape. Let me try and draw it in. There we go. It's an upside down F in this case. And this rule is sometimes called the Z angle rule. So because if I sort of draw around the two red angles that are the same, I get a Z. However, you're expected to remember the words corresponding and alternate. So the third rule, guess what? Isn't a new rule at all, because it's all to do with corresponding angles. So let's consider this angle here, which is angle ABE. Angle ABE. Now, corresponding angles tell me, sorry, in this case I should say my parallel line's going in the opposite direction, but it doesn't matter. Angle ABE, corresponding angles tell us that's the same as angle DEH. Now, these two angles are not the same. They're not the same, but I know that angles in a half turn, angles on a straight line, add up to 180 degrees. So I do know that the red and the green angle add up to 180. And that means, because this angle is the same as this angle, those two angles must also add up to 180. So in this case, I've got angle ABE and angle BED, that one. Those two angles there add up to 180 degrees, and those are referred to as allied angles. They are the angles contained within the parallel lines, and you've got another pair of allied angles here. This angle here and this angle here also add up to 180 degrees. Sometimes they're referred to as C angles because, although I'm at 90 degrees, you could think of that as a C, but you are expected to remember the phrase allied angles. So here's a question that says, find two angles and explain why, give reasons. So firstly, we're asked to find angle EBC. Now I'm going to identify that on the diagram first. I'm going to use green. If I go E to B to C, this is the angle I've drawn, this one. So looking back at my three angle rules, corresponding, alternate, allied, I have to ask, are these two angles the same? They're clearly not the same, are they? This is an acute angle, this is less than 90, and this one is an obtuse angle, it's between 90 and 180. So these can't be equal, so they're not corresponding or alternate. They are contained within the parallel lines, so they must be allied, and that means they have to add up to 180. So I know that angle EBC is 138, and I'm just going to say because of allied angles. And this is a standard framework that I want you to get into the habit of using. Angle equals number because, and then just name the rule. And that could be in a non-parallel line question as well. It could be because of vertically opposite angles, or because angles in a triangle add up to 180, or because angles in a straight line make 180. This framework, angle, number, because rule, is pretty standard. Okay, let's switch to red, ABE, so I'm going to identify that in the diagram first. A to B to E, that's this angle here. Okay, now they look about the same. Not corresponding, because at this junction, 42 is the top right, so that's corresponding to that one. But they are the same, and it makes a Z, so these two are the same, they're both 42 degrees, and that's because they are alternate angles. Okay, can I offer you two hints before I get you to try some problems for yourself relating to parallel lines? Firstly, hint number one, extend the lines in a problem. So in this case, we've got a parallelogram. One pair of parallel lines and another pair of different parallel lines. They're different, obviously, and they're identified with double arrows rather than single arrows. And I'm going to extend the lines in this problem, because at the moment it doesn't look like those ones we were doing just a second ago. But as soon as you extend the lines, it starts to look a bit more like one of those problems. So straight away I can identify that here I've got a pair of allied angles. Okay, that was the third angle rule. So they add up to 180, so that's got to be 108 degrees. And then if I consider these two parallel lines, here I've got another pair of allied angles. Would it help if I turned my diagram that way? So here I've got another pair of allied angles. So these two angles have to add up to 180, and that means that one must be 72 degrees. And that gives you the property of a parallelogram that opposite angles in a parallelogram are equal. So those two will be 72. And adjacent angles add up to 180. So those two add up to 180, and these two would have to add up to 180, so that's 108 as well. So opposite angles there are the same. So extend the lines, that's my first tip. And my second tip is remember the other angle rules that we already know. Okay, so this looks like a parallel line question, but actually it isn't. We're asked to find this missing angle here, and in the middle of this diagram I've got a triangle. And I know the angles in a triangle add up to 180, so 35 and 55 make 90. Angles in a triangle make 180. So here I've got, this has got to be 90, it's actually a right angle. Didn't mark it as a right angle. And then here I've got a half turn, haven't I? 3 angles which must add up to 180, so that means that x has to be 40 degrees. Okay, attached are some questions, and as always you've got the solutions as well. It's probably helpful, I say it's probably, it is really helpful if you either print this or draw the diagrams out for yourself. I don't mind which one you do. But you know, it's really hard, I think, to do this without a diagram in front of you. I realise not everyone's got access to a printer. Hopefully you can draw them all the same. And if a question says, give a reason, then you just need to do one of those sentences that we had in the previous in the previous part of the video, where you just say, doesn't have to be a paragraph, it's just the particular angle equals whatever number it is because of, and then the rule. And you don't need to go into great details, just mention the rule. Allied angles, corresponding angles, alternate angles, angles in a half turn equal 180, angles in a triangle equal 180. And as always, read the instructions in class charts so you only do the questions I ask you to do, and that way you're not doing too much practice. Okay, you will hear from me again on Friday.